Alright, good morning everybody. I'm going to see if I can't help you get through some of this work. Just a reminder, these videos are all on the class website and you can access this from home. I apologize, I'm going to have to talk a little bit fast because there's a limit to how long the videos can be. And I'm obviously not going to be able to do every single problem, but I'm going to see if I can at least try to help get you started. Maybe answer some questions. Alright, so looking over here, you got square root of 25. That's pretty straightforward. That's going to be 5. Alright, then the problem we run into is when we have this problem where it's not a perfect square. 25 is a perfect square. That was easy to do. So what I want to do is I want to identify two numbers that multiply together to get 45, but I want one of them to be a perfect square. In this case, I'm going to use 9 times 5. And 9 is a perfect square, and so all I've got to do is take the square root of it, and that leaves me with 3, and that moves outside now. The 5 I didn't take the square root of, so that stays under. Take a look at the next one here. I've got 32. Now again, keep in mind, the square root, or the perfect square, can't be any bigger than the number itself, so the next biggest one is 25, and obviously that doesn't divide evenly. And then you go down to 16, and in fact, 16 times 2, whoops, let's try this again, 16 times 2 does equal 32. And I can take the square root of 16. The square root of 16 is 4. That comes out. And then this 2 stays inside. Now down below here, what's happening is we're doing pretty much the same thing, only the difference is we're adding some variables. So let's go ahead and start with the numbers. The numbers are going to work the same way. If I want to look for a number that multiplies to get 60, and I want it to be a perfect square, I can use 4 times 15. Now, I look here at the x squared. X squared is a perfect square. What times what equals x squared? X does. Now the thing is, if it's got an even exponent, it's going to be a perfect square. If it's got an odd exponent, it's not. Now here's all we've got to do. This one is going to stay the way it is because it's a perfect square. I need to separate this into a perfect square. Now the nice thing about it is, since even exponents are perfect squares, all I've got to do is take away 1. And then multiply those two together. What's y squared times y? It's y to the third. So really all I've done is separate them a little bit. But now I can see all the perfect squares. And what I do is take the square root of the perfect squares. So square root of 4 is 2. I can't do that one. Square root of x squared is x. Square root of y squared is y. And then the y and the 15, I couldn't do them, so they stay underneath. Take a look here. I've got 90. I can do square root of 99 times 10. The x squared times x can make x to the third, and I'm going to leave 1 to the fourth by itself. So what's the square root of 9? That's going to be 3. And then the 10, I can't do that, so I leave it inside. Square root of x squared is going to be x. I can't do the x, but then the y to the fourth is going to be y squared. That's the square root there. And then everything I couldn't do stays underneath. Alright, now if you take a look at this one, this is a little different. What I've got is I've got a radical, but I've got a fraction inside it, and that's just against the rules. So we've got to get rid of it, and there's a couple different ways to do it. One thing you should take a look at is see if you can find a perfect square. And you'll notice 36 is a perfect square. And what I can do is separate these guys. This is the same thing as square root of 17 over square root of 36. Now the reason I separate them is because I can do the square root of 36. That's going to be 6. Now this top part is going to be the same as it was before, and that is simplified. That's okay. I'm allowed to have a radical on the top of a fraction. I can't have it at the bottom in the denominator, and I can't have the whole thing be 1. So it runs into this problem next where I've got a radical in the denominator. The easiest way to get rid of that is to multiply both the numerator and the denominator by the radical that you're trying to get rid of. Now if we start at the top, 3 times square root of 3 is just 3 times the square root of 3. And then square root of 3 times square root of 3, that's going to be the square root of 9. Now, I can do the square root of 9. Square root of 9 is going to be 3. So I rewrite the top, 3 square root of 3. But then I take the square root of 9, and that's going to give me 3. And now I notice that 3 divided by 3 is going to be 1. And so my answer is just going to be square root of 3. Now, the last one over here that I'm going to do in this top part is where they're going to be adding these. And you'll notice that I've got the square root of 3 and square root of 3. I can combine them if they have the same number under the radical. I can't if they don't. So these guys do. So it really is the same thing as saying 1 minus 4, or negative 3. And then I just bring the square root of 3 along. And I didn't do anything with this, so I can't leave them out, but I can't change them. Alright, so next part. I've got, how do you find the square root? Basically what you're finding is you're finding the two factors of a number that are the same. When I'm looking for the square root of 25, what I'm looking for is the number that I multiply by itself to give me 25. So that's going to be 5. So now I've just gone to over here. This is cube root, and many of you know what the cube root of 8 is, but let's go ahead and show you how to do it in the calculator. If you go to the math key and slide down here, you'll see a cube root button. So you press enter, and then put the 8 inside there, and you'll find out that it's 2. The cube root of 8 is 2. And what that means is that 2 times 2 times 2 is equal to 8. So if I do the same thing here, cube root 343, I find out that 7 is the cube root of 343, or 7 times 7 times 7 is going to equal 343. So what's it mean to find the cube root? It means that we're finding 3 factors for a number that are the same. Alright, so we go to this next part. If you take your calculator and you go and raise this 36 to the 1/2 power, I've got 36 to the, now the thing is, use the little caret key by the clear button. Now I'm going to have to use parentheses, but your yellow calculators won't. I do 1 divided by 2, and then you find out it's 6. If you do this one, 27 to the 1/3, 27 to the 1 divided by 3, and you're going to find out that's 3. If you do all those, what you're going to find out is that, hopefully, that when you raise a number to the 1/2 power, it's the same thing as finding the square root. And if you raise a number to the 1/3 power, it's the same thing as finding cube root. And so it would be the same thing. If you raise something to the 1/5 power, that would be the same thing as finding the 5th root, and blah, blah, blah. It keeps on going on forever. So what happens is it helps us change things around if we want to. It works to our advantage. We can change things. For example, you know this is right here a square root. Now think about it. When you square something, you're raising it to the 2nd power. So that means this is a 2nd root. So really, I can rewrite this as x to the 1/2. Now this is going to be z to the 1/5. Because it's to the 1st power, and it's got the 5th root. The 1 goes on top, the root goes on the bottom. Here, this is y to the 1st, so it's going to be y to the 1/3. This is going to be 5 to the 1/2, because again, this is a square root, there's a little 2 there, even though we haven't written it. And then we can go the other way. Here, if you take a look, I've got x to the 1/3. Well, that's the same thing as the cube root. And so when I do that is I just put a little 3 there by the little index number. And then here, if I want to find the y to the 1/2, that's the same thing as the square root of y. Now all I'm doing is rewriting these. I'm going back and forth. I can take this and make it with an exponent, or I can take this with an exponent and make it with a radical. So one more. This is going to be z, but it's going to be to the 5th root. Now here, you'll notice this has got a square. So what happens is it is x, but it's x squared, and then the root is 3. And then here I've got y squared, but it's a cube root of that. Alright, so I'm about out of time. I'm going to have to you do a different video for the back side of this. I'll talk to you in a second. Thanks, bye.